Next concept in Python is operators. A plus B. So altogether it is going to be perform the task or what the action it is going to be perform is an operation. A, B are operands, plus is the operator. Altogether it is going to be perform some operation that is called as A plus B. Altogether it is performing some action that is called as a operator operation. Now different types of operators what we have here, it's first one arithmetic operators, assignment operators, relational operators, logical operators, bitwise operators. First, arithmetic operators will discuss what are arithmetic operators we have. They are used to perform arithmetic operations. So those are addition, subtraction, multiplication, division. So division here, quotient is answer. Quotient is considers answer after dividing A divided B. In float value. We are going to get the float value. So float division, this will be considered as float division. After division, A divided by B, quotient is answer with the nearest integer, but it is not going to be give the exact result. Like 3 divided by 2, in a sense, the exact one we can able to get only with division operation, but not with the floor division. Modulo division. This is modulo division. After A divided by B, remainder is answer. So because of that, we are going to be consider this modular division operator as remainder operator. As well. Next, exponentiation we have. So this is exponentiation. A exponentiation B, in a sense, A to the power of B. It is going to be calculated like A to the power of B. Like this, we are going to be calculated. So we'll see the examples on this. Subtraction, multiplication is general. How we are going to be perform the task is similar that in general mathematics. Now, if I am considering n1 value as 10, n2 value as 20, n1 value is 10, value is 20. So now n1 plus n2 will be getting 30, n1 minus n1 into n2 minus 3 we are going to be get. Now n1 divided by n2. 10 divided by 20. So we are going to be get value here 0.5. n2 divided by n1. So we'll be getting 2.0. See, now we are getting here n1 divided by n2 0.5. Whenever I am performing this flow division with n2, will be getting 0. Exact decimal value we will not get it here. So 9 divided by 2 will be getting 4.5. 9 floor division 2 will be getting 9 floor division 2 4 we are going to be get. So if suppose 9.2 any one of the operand with the floor division is float value, then we are going to be get the result in terms of float value, but with the nearest integer dot 0 it is going to be get. See, we are going to be get will be getting 4.0 only. So actually 9.2 divided by 2 will be getting here as 4.6. But here we are going to get 4.0. Any one of the operand or both the operands or decimal values also will be getting the decimal value when we are performing the floor division. But still, it is not the exact decimal value after dividing that number with another number. Nearest integer with dot 0 we are going to be get as a float. 9.2 floor division with 2.1 will be getting like 4.0 only. 9.2 division with 2.1 will be getting here as some value 4.3809 something. Next we'll see the floor division. 9 floor division, sorry, modular division. 9 modular division 2 will be getting as 1. So 4 modular division 2 innocence will be getting 0. If the numerator is smaller when compared to the denominator, so then we are going to be get the numerator as the uh, remainder when we are performing the modular division. So this is modular division. Exponentiation 2 exponentiation 3 2 to the power of 3 it is going to be calculated. So 3 exponentiation 5 in a sense 3 to the power of 5 it is going to be calculated. 3 to the power of 5 it is going to be calculated. This is what exponentiation operator or exponentiation operation how it is going to be worked. Similar to the power function. Next we have assignment operators, which is this is a assignment operator. The value what we have at right side of assignment operator will be assigned to a variable at left side. So now as for this, we'll be getting this as value 10 assigns to variable x. Value 10 assigns to variable x. So compound expression if we have also, we can able to evaluate the compound expression and we can able to assign that to the single variable. Like this we can able to write. But instead of that, the variable 10 is going to be assigned from variable x in a sense. The value 10 is going to be assigned from variable x. This is going to be give the semantic error because the variable cannot be assigned to a value. So the compound expression cannot be assigned to a the compound expression cannot be get assigned with a single value. So in this particular case, here also we will be getting the semantic error. So the different types of assignment operators we have here is addition assignment operator, subtraction assignment operator, multiplication assignment, multiplication assignment, division assignment operator, row division assignment operator, modular division assignment operator. How these operators will work? See, now A value is 5 we have. A value is 5 we have. A addition assignment 2 innocence. How this is going to be evaluated is A is equals to A plus. So we'll be getting as 5 value. A value is 5 previously. 5 plus 2 will be having 7. So if I'm seeing the A value here, we'll be getting as 7. The same will apply now. So remaining operators also will be similar to that only. So instead of performing addition, with its respective values, it is going to be performed. A value is 5 we have taken here. And here A addition assignment to 2 innocence will print the value of A. So 7 we are going to be getting. So A subtraction assignment to 2, subtraction assignment to 2. So after that we'll print the value of A, we'll be getting 5 again. So in the similar way, we'll be having multiplication assignment A multiplication assignment to 5. 5 5 is 25 will be getting the output. So in the similar way, we are going to be perform the remaining assignment operators as well. Uh, that is assignment operators. Next we have relational operators, which is to compare two operands and which returns the result as uh, true or false. Or false, that is boolean value. Used to compare two operands, which returns the result as true or false. So simply we can say use it for writing conditions. Conditions. What are those we have? Equals to, not equals to, less than, greater than, less than or equal to, greater than or equal to. These are the relational operators we have. So equal to, both the operands are, so because of that it is going to be written true. Like I mean 2 equal to 3, the condition is false. Because of that, it is going to be written false. So like that, for writing the conditions, we are going to be use the relational operators. After writing the conditions to combine more than one condition, we are going to be use the logical operator. Logical and logical are logical not that is for combining more than one condition. That we will see here. And logical and logical or logical not operator. See, if x is one operand, y is another operand, x and y, how it is going to be work? X or y, how this is going to be work? Not x, how this will see. So when we are considering two conditions, the possible values will be false, 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 true, false. See, logical and will be true, it will be only when both the conditions are both the conditions are otherwise false. Otherwise it is false. When we are coming to this, it will be when at least one condition is, it will be true when at least one condition is true, otherwise it is false. Otherwise it is false. Only when both the conditions are false, it will be, yes, it will be true. So not of x innocence negates, like if we have, will be false if the value is false, not of not is, and vice versa. So like this. If you see here, both are false. For AND operation, it will be false. False true, it will be false only. It will be true only when both the conditions are true. So here itself, here also it will be false. And both are true. The resultant will be, see, both are false. For the logical OR operator, it will be false. False will be false true will be. So here OR operator true false will be true. Both are true. The resultant will be, otherwise it will be not x. False if we have, not of x will be, not of x will be false. So not of, if x value is false, not of x will be, if x value is true, not of x will be false. If x value is true, not of x will be false. These are logical operators. Next, bitwise operators, which are used to perform operations on bits. Operations on bits. Which are used to perform operations on bits. So that is bits in a sense, zeros and ones. Zeros and one. Everything we are going to be perform the operations on zeros and ones. Which is bitwise and bitwise or bitwise not, bitwise XOR, exclusive or left shift, right shift, left shift and right shift. See, logical and bitwise and will be same. Logical and is to perform the operations on false, but here we are going to be consider 0 and 1. 0 will be considered as false, 1 will be considered as place for that it is going to be work. So x, y, x bitwise and y, x, x or y, sorry, x or y, x, x or y. XOR operation will be, that is exclusive OR operation will be, if both operands are, the resultant will be, both the operands are 1, then the resultant will be 1. Otherwise, it will be, uh, sorry, both are 0, it will be 0. Both are 1, it will be 0. Otherwise, it will be 1. We will see the possible cases of this will be 0, 0, 0, 1, 1, 0, 1. Both are 0, it will be 0. 0, 1 also 0. 1, 0 also 0. 1, 1 will be 1. XOR operator X or Y. So if any one operand is 1, the resultant will be 1. So here also it will be 1. Here also it will be 1. Here also it will be 1. Both are 1, it will be 1. XOR operation, when we comes to the XOR operation, here it will be 0. And in this case also we will be getting 0 because both are 0, both are 1. In this particular cases it will be 0. Otherwise it will be 1. So left shift operators, which is used to uh, rotate or shift to bit positions if I'm representing 2 towards left, right shift in bit position towards right. Everything it is going to be performed shift wise. That is bits wise. 0, 1, 1, 0. If I'm giving x value as 1, 0, 1, 0, x left shift of 2 innocence, it is going to be towards left. X right shift innocence, 2 bit position towards right, it is going to be. Other operators have here is other special operators. This identity operators, identity operators, membership operators. So identity operators will be is not, in, not in. So this we'll discuss in the coming sessions, and the examples of this operators also will discuss in the coming session.